X is
So go ahead.
X. X would be the weight, the 0.5, the 50% you're gonna allocate to
Exactly.
each of the.
Exactly. So we're creating, so we're going to work with these two here that I introduced last class. And we're going to combine them. As it says here, consider a portfolio P with two assets, 50% invested in A. So that represents XA, 50%. We'll use the decimals. And 50% in B. So that's XB. The portfolio expected return is given by, so this is going to be the expected return of the portfolio. It looks like this, but what it's saying is, so I'm creating a portfolio of partly invested. So I said to you, let's say if I invest $1,000 in RP, then how much goes in each? $500, okay? Which makes 50%. And how do I calculate the expected return of that? The expected return, let me make sure. The expected return of an average, this is an average. We'll call this a weighted average, even though it's like 50 of that and 50 of that is just like an average, right? RA plus, this is the same, since it's 50%, I could have written it as RA plus RB divided by 2. Does everybody agree? But I'm going to write it like this in general because it doesn't have to be 50. I could have used a different percentage. As long as those percentages add to 100, I could combine the stocks like that, or spend my money that way. So the rule is the rule of means. If you didn't learn it, no, no, it's going to sound weird. Let me say it this way. The mean which means average anyways, the mean of the average of two variables is equal to the average of the two means. So all this is doing is saying you're gonna average their means using the same weights. Okay, so the mean of the average, and I'll do it down here. So the E acts like an operator. It's called an operator. And if you want the average of a combination, what's called a linear combination, when I add variables together, this just passes through, like it distributes through, but just to the variable. This is not a variable, this is a number, like this is the 50%, 50%. Okay, so I said it in words here. This is the mean of the average of A and B. Oh, I didn't write the B. Is equal to the average of their means. Okay? So whatever you do to the whole distribution, Like this is happening to the whole distribution of R. Like just think about this being like a normal distribution, and this is another normal distribution, and we're adding those together and creating a new variable. And so the average of doing that is just going to be the average of their own means. Anyway, I don't know if you guys learned that before, but now you know, okay? So we're going to use this form. So it's just a weighted average. So can you guys calculate that for me? Tell me what you get. So XA is 0.5. What was RA?
The answer is 6.5.
Yes, because it's just the average of 6 and 7, right? It's the perfect average of 6 and 7. That's right. So it's just like, because of the doing it this way, it's just like 6 plus 7 divided by 2, right? Because it's half and half. So it's right in the middle, 6.5%. Is that okay with everyone? Did I skip any steps there? Okay, that was not hard. That was the easy part. Now we're going to calculate the standard deviation. What is the standard deviation of this new variable, RP, returns to this portfolio? What is the standard deviation of that? That's the next question. First of all, do you have any questions about this? Because I'm kind of going quickly.
I believe we can do the same process, the weighted
Okay, so
standard
let's do that.
deviation.
So the VRP, we'll go with the variance first. We always work with the variance, right? Because we have to work with the variance first and then take the square root. That's usually what we do. So we're going to work with the variance first and use the V as the variance operator and try the same thing. The question is, can I do this? That is the question. So you guys can copy that if you want, or just follow along. I don't mind if you copy, but don't let it distract you from listening. That's the trick. So the question for you is, can I just do this? Can I just average these two standard deviations? You can put it in the chat. You can say it out loud. What do you think? You can read ahead, but I want you to think before you read ahead. Unless you've already seen this material.
Yes.
Okay, yes. You think yes? How many people think yes? How many of you think it's that easy? I'm giving you a hint. It's not that easy, okay? It is yes if something is true. If RA and RB have no relationship or interaction, that's true. In other words, if covariance of the returns to A and returns to B is 0, that is true. That's the only time, okay? So that's true only if RA or stock A and stock B we'll say are independent or uncorrelated. So in other words, the covariance between stock A and stock B's returns is equal to 0. That's the only time that's going to work. And sometimes you'll get some problems like that. So you look out for that. It makes it much easier. That's not even like that. There's still one more thing I have to fix. What do you think? There's one mistake here. Can anybody catch it? What is the one mistake I made in writing this? So it's kind of like this pattern, which kind of makes sense to you, but there's one mistake here. What did I tell you about variances and their units?
With variance, it had power.
to the power of 2.
It always has to be squared. Everything gets squared in variance because then we have to take the square root to get the standard deviation. So there has to be, the weight gets squared. And I'll explain that a little bit later, where that comes from if it really bothers anyone. So that is true. That formula works if they're perfectly, like there's no correlation between them. So there could be two stocks that are uncorrelated. You guys can think about examples to help you. Maybe I'll ask you again next class. Think about examples of correlated and uncorrelated stocks. All right. Think about industries that are uncorrelated in their productivity. In general, however, that's not the case. So let me go here. So here it is. In general, the variance that we write like this, so you can write it like that, variance RP, or like this, right? Because again, the distribution has, the distribution had 3 possible outcomes. Sorry, I'm going to have to remember if it was 2 or 3. 2 possible outcomes, right? And there were 2 possible outcomes. We can write like this or like this, and it's the population data, so we use the Greek letter. And don't forget the square, because this is the square version. When I take the square root in the end, I'll get to the standard deviation. All right, so here is the portion that we already have. That's the way that's variance of A and that's variance of B. Are you guys good with that? So if I go back here, I could write that a little again to look exactly the same. XA squared sigma A squared plus XB squared sigma B squared. That's what we decided. That's true. And it's simpler as long as there's no correlation. But if there is a correlation, we have to account for it. Because that's going to contribute to the overall variance. If you're holding both stock in your portfolio, you're going to have exposure to both of them. And if they're related to each other, you have to think about how that's going to impact your exposure to the volatility of those, of holding them together. So there's this extra term. This is the extra term, which if this, what is this again? This is the covariance of A and B. If the covariance of A and B is 0, then this falls away and you're left with just that. So last class, I asked you to calculate the covariance of AB. Some of you got it, some of you didn't. Some of you maybe went home and looked at it. Some of you didn't. You need it, okay? So we practiced it so we could calculate it today on that test. We practiced it. So you could calculate it here today. And this is, you know, it's kind of ugly and busy, but you can just go back to your other, just remember, it's just 2 sets of brackets twice with the p's here. Okay, and the means here. And then the values for A here and the values for B there. It's not that bad when you get the pattern, okay? So you're doing the deviations from the mean of A and B, and then you're going to pre-weigh them and add them up. So can you guys do that for me? Can you try that? That will give you the variance, and then we have to put everything together. So let me get the data again. So you really need this data set here. And you need the data, right? You need the whole chart. You need this. Okay, I'll give you a few minutes for that. Where'd it go? Confusing myself here. Okay. There, sorry. So there's all the stuff you need. So calculate the covariance without looking at the answer. Try it yourself. I'll make it a little neater. So go across and store 1 and store 2. And add them together. Use the brackets, take your time. We did this before, or you tried before. What did we say about the data also? Look out for the fact that we talked about this. Remember, the relationship between A and B was inverse, so it should be a negative. Your answer should be a negative. Okay, anybody got some answers for me? The first one, I think is, what'd you get for the first one? Is that right? Did you get that? I could have it wrong. Recall 2. And this one, anybody? It's not the prettiest arithmetic, but it's doable. I got a different answer. Okay.
I got that answer for the first one.
But the second one?
I don't have that one yet.
Okay, try and get that one. Confirm with me. I keep getting different answers now.
I'm getting like 0.00018. I'm gonna do it again.
No, I get a different answer. I get a different answer for this one every time. So you guys tell me what the second one is. Okay, I keep getting 0.01728.
Yes, that's what I got for the second one.
Okay, let's go with that. It looks better with my result. Okay, so this is negative 0.01728. So you guys got to practice, you know.
We're multiplying the negative 0.1 by, oh, sorry. So I'm supposed to do like the parentheses for the calculator.
Say it again.
Am I supposed to use the parentheses for the calculator, or
You're supposed to calculate across. Yeah. So you can simplify, do whatever you do. I mean, you guys practice. I mean, this is just algebra. So 0.2 negative minus arithmetic minus point. So you can simplify them and multiply them or use the brackets. This one is negative 0.27, and then the other one is 0.3 minus 0.06 is 0.24. And if you multiply across times 0.27 negative times 0.4, you get that answer. So you can do it in bits. So when you put it all together, recall 1 plus recall 2, your answer for covariance, and I'm not saying it's easy, I'm just saying you have to practice. You can't be at the position number 1 or like at the beginning constantly. You guys have to practice. You have to move beyond this. This is just a tool, adding, multiplying. It's not, you're not supposed to stop here, right? This is just a tool. So then this is going to be, when you put it all together, 0.0432, and it is a negative as we suspected. We don't understand exactly how correlated they are. So why don't you guys also figure that out and then tell me, what is the correlation coefficient? What is the correlation? This is the covariance, but we know the correlation of AB will be the covariance AB standardized. So get this calculation for me and tell me what you get. Because remember, covariance, we don't have a real handle on what is 0.0432. Is that strong? We don't know. It just tells us the direction. Covariance just tells us the direction, not the strength. So you have all this data on this page to get me this number. You guys need to verify all this. We can't spend time making calculations in class, even though I do it. You have to verify. So if I seem abrupt, you're going to have to practice and verify these results when you study. Actually, I'll put it here. So this is negative 0.0432. And A is 0.196 and B is 0.22 that I have right here. And when I put it all together, what do I get? Anybody? You guys are taking forever. Are you there? Are we there yet?
I got negative 1.001855288.
No. You cannot have a correlation that's more than -1. So you did something wrong. Right? Correlation has to be, R has to be between -1 and 1. Same with correlation is between -1 and 1. So as soon as he said 1 point, I knew he was on the wrong track. So there's just something, I don't know. Let me do it.
Point 00100.
No. So what is happening? 0.196, let me see, divided by 0.22. Okay. So what's happening here is that this will be, because it's rounded, because these are rounded results, oops, hold on. Because these are rounded results, like these ones and this one, like all these results were rounded, right? If we didn't round them, we would get -1. So even though, David, you had 1 point, what'd you have, 1.008?
Yeah,
Okay, so so basically it's over 1 because the other ones were calculated by rounding and presenting, you know, this with no decimals and this one with 1 decimal and this one too. Because it's dependent on those, it ends up that you're over. But this is -1 if you don't round. Okay, so these are perfectly negatively correlated. So in other words, you found, this is like the unicorn situation. It's very unusual. It's fantasy, you know, that you're going to find two perfectly negatively correlated assets and hold them together. What we're more interested in, if you do have perfectly negatively correlated assets, you want to be able to, and actually you will be able to find the best combination to completely eliminate all risk. In other words, your variance will be 0. But you have to find the right combination. I just told you 50-50, but there's a way to combine them and spend your money. In this case, we're spending it 50-50. But there's a way to combine your money so that you combine, sorry, the assets and your spending so that you have absolutely zero standard deviation or zero variance. So let's continue with this exercise. We have the covariance here, and we're going to put it now in this formula. So now, if you guys can go to the next step, take your time and enter all the values into this equation, you will get the variance. What do you get? Remember that these weights have to be squared. So you can use the original variance. So the variance that we got here, I'm going to go all the way back because the variance was calculated here. If you use this variance rather than this, because this is the square root of this variance for asset A, and that's where the rounding happened and it messed everything up. If you actually put these values into that formula and you square them, you'll get exactly -1. So use these as the variance. Don't use these as the standard deviation because these are more pure. Okay? Before it got rounded here. So 0.0384 and 0.0, I'll copy them. So these are actually sigma A and sigma B. If you put those in the formula down here, you'll get 1 perfectly. If you want to check. Okay. All right, so I'm going to give you 5 minutes to put everything into here and tell me what you get. And then think about what it means. So we're almost halfway done this set of notes. That's good. We'll finish on Monday. Okay, so anybody who wasn't looking at the moment, I just replaced these here with the variances, square root of the variances, so that we would get exactly -1. I should pause the video when I give you time to work, but then I worry because I forget to turn it back on. Okay, I did. Okay, there's room here. All right, so here are all the values. I pluck them in using the variance version rather than the standard deviation. And then don't forget the 2 and the weights and the covariance, and this is what you get. This is your variance. It's very small. And when you take the standard, when you take the square root, this is now your standard deviation. This is the standard deviation of the portfolio. So let's go back and look at our data set again, or our two variables. So this is what we had before. We had variable X. Hold on, I don't see my screen. So we had a variable A, sorry. So variable A or stock A has an expected return of 6 with a standard deviation of 19.6. B had even greater standard deviation, but if we put them together, if we combine them, look at what happens to the standard deviation. Now keep in mind our expected return, or our mu of the portfolio, is 6.5%, but so what? When you get such a reduction in your standard deviation, within 3 standard deviations of the mean, you're still in positive range of returns. Right? If I did 3 standard deviations, so if I did 6.5 plus and minus 3, 1.22, so that's x, well, I'm going to call it x, I'm going to say mu plus or minus. I'm still in the positives. There's no negatives, no negative returns, all positive. That's pretty good. Not high, it's like not like 12 or 15, but I don't have negative return. This is like a guaranteed income. Okay, that's what it's telling me. So why did that happen? Why did this happen? Why is it like, you can think about it, well, anyway, just tell me, why did it happen? What made it happen?
Because they both cancel out almost.
Okay, yeah, so you're thinking about the -1, right? So the -1 correlation means that when one does poorly, the other one compensates. That's an perfect example of hedging. Okay, that's hedging. So you hear about hedging, right? So you're hedging your risks. When one does poorly, you already have a backup plan. The other one's going to do well, and it does it perfectly, like Alvaro mentioned. So it reduces your fears or your risk, right? It's gone. So this is what's happening, and mathematically it's because this is negative. Okay, so that the idea of negatively correlated assets is captured in this calculation of the covariance. All right, so any questions about that? Are you surprised? So this is why we put stocks together that are different from each other. Right? Opposites attract. No, like this is basically why we do that. And this is the notion of diversification. All right. And this was only for 2 assets. The advantage was they were perfectly negatively correlated. That's going to be hard to find in general, to be perfectly negatively correlated, but this is the extreme example. Okay, before I continue with the discussion, any comments from you? We did this with 2 assets, but we can use the same logic, and portfolio managers do, to combine more than 2. The only challenge there, remember the expected return formula here was for 2, and that was pretty easy. What if I add one more? Let's say I had stock C. What would the formula look like? Right? And the expected return would just be, remember the P stands for portfolio, to be different from the rho R correlation coefficient looking P. It's not a P, it's actually a Greek letter R when I use it for correlation, just to be clear. So if I wanted the mean of that, then it's just going to be XA mean of returns on A, XB means of returns on B, plus XC means of returns on C. Ah, that's it. Okay, so what about the variance? What would that formula look like? So that I'm going to give you guys another chance at that.
Would it be x2a mu 2a plus x to the power of 3b?
3?
And I mean a to the power of 2b mu
Uh-huh.
2 to the power of 2b, and then the same with c, and then instead of 2, would it be like 3xa xb xc
So
mu?
that's exactly your instinct, right? And maybe it's 3 because it was 2 for 2, so it should be 3 here for 3. And that is, most students will think that, but I'm going to show you why it's not that way and where we even got this thing from. Okay, the long one. So let's do that next. Okay, let's let you catch up, and then we're going to do that. Okay, so we're going to come back to this. So where does this formula come from? That's what we're going to talk about. And I'm going to show you, and you're going to get it, and you're going to feel really good. Most of you will get what I'm talking about, but I need to be caught up. Are you guys caught up in your note taking, whatever you're doing there? So what we got to do is we got to build a matrix. So I'm going to do this for, I'm going to do it for 2, and then you're going to tell me how it works for 3. So here's my matrix. I'm just going to put A here, so with its weight, and B here with its weight, and that's a B. I don't know why I wrote X, B. And then do the same thing here. And what we're going to do is use this to help us, because with 2 it's easy, but then it gets more complex with more than 2. So what we're going to consider in creating the formula for var, or variance of RP, where RP is equal to XA RA plus XB RB, we're going to consider each pair and their relationship, the covariance, the contribution of their variability to the variance overall formula of the portfolio, okay? So we're going to write XA RA here and XA RA here, because that's what I'm doing. I'm going to relate, actually leave some space. And then I'm going to do the same thing for covariance XARA, XB. So now I'm going to look at the covariance of the two different ones. And then here I'm going to do covariance XBRB. So when you use a matrix, you always go across first and then down, right? So I put the first, the across, the horizontal one, and then I put the vertical one, XARA. And then here, covariance of, so first XBRB, but then it's the same thing. So I'm considering in pairs the contribution of the covariance and the relationship contribution of variability caused by their interaction. So what is covariance of XARA and XARA? Does anybody know what that is? So I'm gonna write it out, and I'm going to do it. I'm going to write this out. I'm going to express this just to show you the pattern, but I'm not going to use the weighted thing because it's just a little more confusing to look at. Think about historical returns just for a moment. Oop. Okay, so covariance of XARA with XARA is equal to 1 over n minus 1, 2 brackets, right? XARA minus, and what goes here? This is the mean of XARA. What's the mean, or the E? That's what goes there. And what did I just teach you about the E? The E latches onto the variable, not to the XA. The XA comes in front. I have to create so much room. Sorry, you're going to have to use a pencil. And ERA. Okay, everybody okay with that? Because that's what should be there, but I'm going to skip a step or do 2 steps in one. So the mean of XARA is just XA times the mean of RA. So I can explain that more if you guys don't get it, but anyway, leave that there. And the same thing is going to happen for the other one. All right. How can I simplify this to make this look like something that we know? Can I
Square.
Hey?
Square the two parentheses.
Not square, but I can factor out. I can factor this out. There's a square here. You're right, Nicholas. But where does it come from? I can factor out XA of here and factor out XA from here. And that's where you get the square from. You see?
But aren't the two parentheses the same thing?
Exactly. That's what
Shouldn't
you're
they
talking about,
be?
the square. Yes, yes, yes. But first I'm going to clean it up. First I'm going to clean it up a bit. And then I'm going to do that. You're right. So this is, you're right. So this is going to be XA, 2 of those, and I can put it inside or I can put it outside. I'll put it inside for now. And then RA minus ERA and square. All right. Now, one more thing. Can I just write this XA outside? Remember, XA is just like 0.5. It's just a number. It's a scalar. It's called a scalar.
What I didn't understand was that why did we start doing the weightings for the same
Because I have to do it
the
for the
same
other
variable?
ones. So as I have to do it for all of them. So it started with that one. But it has to, you're going to wait because that's what you're doing. You're only having a fraction of RA, not the whole contribution of RA. It's not $1,000 of RA. It's just 500, for instance. Is everybody okay with what I did here? Here's my XA. I can bring it all the way out. I can bring it out of the bracket, but I can bring it all the way out in front. So now you're going to tell me, if you're just watching, if you're writing and you're lost, just pay attention right now. What is that? What is that I underlined? Stay with me, stay with me. What is that? What does it look like? It's the deviations from the mean of the variable of interest here. And I'm averaging them. What is this called? This is the average of the square deviations from the mean. What is this called? The average of the square deviations from the mean is called the variance. So that's where that first term comes from. The covariance of XA with itself, XARA with itself, is just this. That's the first term from our formula, right? All right, so this one we can replace with. Now, in that same spirit, I only hope I have to do that once, that you guys get that this is going to be it's going to tell us what this one is. What's this one? How do I simplify this? What's the pattern, okay? Just have to see the pattern.
The same thing you did for XA.
Exactly. It's just going to be the same thing. I'm going to do it on top. It's going to be the same thing, but with B. And that's where that term comes from. All right, we have that last term. Where does the last term come from? What does this one become? You can do it. You can try and write it out for yourself and see what happens with those, with XA and XB, which are different numbers, or don't have to be if they're 50%. But anyway, the point is that they're different scalars, not necessarily the same. If I do that aside, do you guys want me to do that too? So covariance, XA, RA, XB. Just think always where these things come from to understand what we're doing so you can extend it. This is going to be, so using the concept of the sample covariance, this is going to be XARA minus XAERA. Just watch if this is too much for you to copy. You don't have to copy anything because you have the notes. And then this and the videos. And this is XB. If it helps you to write to stay awake, I get it. But don't stop listening to me. And then this is RB. My pen got darker. I hate when that happens. Why did that happen? Because RB. And you see I can do what? Factor out what of here and what out of here. And I can factor out xb here. And what do you get? What's the conclusion? Everybody okay with that? So this is possible because A and B are numbers. XA and XB are numbers. They can be pulled out of these equations or these brackets. All right, so that, are you guys okay with this? This is going to be, oh, I just erased it. This is going to be this one here.
Could you explain how you did the factorization?
Just like I did
Please.
below. I just pulled it. I pull it out in front because there's an XA there and then there's an XB here, and I pull it out in front and it can go all the way in front and front. This is all multiplying. So I can just move when they're all multiplied together, the brackets and the XA and XB, I can just move the order around.
I don't understand the AB. How did you get the AB?
Because there's an extra XA in here and there's an extra XB in here. And then I pull it out both in front. And what does it leave? If I pull out all the way there, and then all I have here is RA minus ERA times RB minus ERB. What is that? What is this? That's the covariance of A and B. So the test that you did last class has come back to bite you, right? It's the same. You have to recognize what the covariance is. I had that on the test because we're going to spend this whole class talking about covariances. And covariance of a variable with itself is the variance. So really at the heart, at the most general, the base is the covariance formula. Even though you guys spend more time on the standard deviation, it's really important to know it's where it all starts with the covariance. And I think I need one more bracket here. All right, so that goes back here. So this one is going to be XA, XB, covariance AB with no square on it. And before you guys go, what is this one going to be?
XB, XA, mu, BA.
Sigma, yeah. Sigma, BA. Does it matter if I put A first or B first? They're all being multiplied. Does it matter the order? So if I wrote it like you said, David, if I wrote XB, XA, covariance, covariance BA, isn't it the same as this one? Does it matter in the covariance formula here if I put this bracket before this bracket or the other way around? Doesn't
No.
matter, right? So they're the same thing. That's why we have two. So these are the same. And that makes two of them. And that's where the last term comes from. Sorry, I didn't see that. That's XA, XB. XA, XB, sigma AB. So that's where the last term comes from, XA, XB. Now with that, you guys are going to go, but think about how will it look for three variables. Now that I did this, do the same table yourself, add an extra term, add XC, RC, and we'll talk about it next class, what you get. Now that you know how it works. And you know where the square comes from. Okay, so this explanation justifies these formulas. I spent a lot of time. I don't want to have to spend it again. So if you need help, let me know soon. You guys can take a picture and stare at it and let me know if I made any typos there. Okay, so the question for next class, Monday, is going to be, what is the formula for three variables? Three stocks in a portfolio. And then we're going to talk about, we're going to finish these notes on Monday. The last set of lecture notes in Unit 5 is just solving. There's no new material there. Well, there is something, yeah, at the end. But we're going to be solving the URKs part 2. Okay, so we're going to finish that next week. After next week, we're just going to meet and do exercises, try and do a bunch of exercises together. You guys should go back. So you've done one pass through all of the notes. Now you have to start studying for the exam. So start with the final exams that are at the top. Some of them are like old exams of the different, like exam 1, exam 2 in the final, or 1, 2, and 3 in the final. Start doing them now. You guys have a few weeks, right? And see where your gaps are. And so when we do have the review classes, you can ask me your questions.
Which problems? Again, could you repeat?
The exams, I have all kinds of exams on the platform. Have you seen them? They're at the top of the platform. They're in each of the units has exams. Start studying them. Let's see. I'm going to share. But you guys have to go to another class, right? But I'll show the pantalla here. So down here, you have these old exams, you see? And then in each unit, I think I have old exams, or at least in 2 and 4 and 6, I have old exams, or 5. 6 for you guys. Unit 6 is going to be just self-study, so I'm not going to work with that. You guys are going to work with that. It's just a few videos. I think it's 3 hours or 2, like 3 hours of videos, and then there are just some notes here to review. The topic of financial statements, financial ratios, and that material. But you're going to spend more time with, and there's more focus on the other units. So just work on that first. At the beginning of the course, I have some exams right here. Exams, see? Exam 3, exam 2, exam 1, final exams. I just have one. And you guys work on them, bring me your questions, or you guys can pick one and I can solve the whole exam online if you want that. Let me know. So hopefully next week we're going to finish and then we can use the last week. Well, I honestly, again, I don't know what's happening with the schedule, but let's aprovecha, then just keep studying, just take advantage. The more days, if we have more days, keep studying. Okay, you guys can go. If you have
Thank you. Good
questions,
afternoon, Professor.
Good
if you have any
afternoon.
questions, yeah, you too. If you have any questions for me, let me know. And I'm just staying here for my next class. You guys can ask me.
I just wanted to ask how many quizzes are left?
None. We're done. With the Pato and everything, it's like there's no way. I was gonna try with my TAs, but I don't think it's not gonna work. I don't know what's gonna happen next week, so we're done. We're gonna meet
Okay.
virtual this week. Well, today. Next week, I don't know what's happening, so we'll just go week by week. In class, we're gonna meet again virtual next week because I'm gonna be gone. I had planned that you would go to the classroom and my TA would be there and she would take asistencia and we'd all be together, you know? Anyway, that was my plan, but let's see what happens for next week. Well, I'll keep you posted.
And I mean, worst case scenario, can the final exam or the quizzes, whatever, can it be like online too? I mean,
Oh,
worst
on a
case
final
scenario.
exam? Oh, yeah, no more quizzes unless somebody's like really desperate. I think you guys are going to be fine. I'm going to put the grades so you guys can see that you're not desperate. But if somebody really needs, well, anyway, I'm saying too many things at the same time. Basically, I don't know about putting the exam online. I don't feel great about that, but I could do that. I could figure out a strategy. There are strategies to do that if I have to. But no more tests. I don't think we need any more tests.
Okay, good. Well, have a good day.
You too, Israel. I'm going to stop the recording, but I'll stay here.